You are designing an e-commerce platform that will experience unpredictable traffic spikes during flash sales. The platform must handle the traffic efficiently, maintain session state across multiple instances, and ensure high availability. The database must also handle millions of read requests during these spikes. Options: A. Use auto-scaling with EC2 instances and elastic load balancing, and store session state in DynamoDB. Use RDS MySQL with read replicas for the database. B. Use auto-scaling with EC2 instances and an ALB, and store session state on the EC2 instances. Use Aurora with global database replication for the database. C. Use Lambda functions and API gateway, store session state in ElastiCache, and use DynamoDB for the database. D. Use ECS with Fargate for the application, store session state in S3, and use DynamoDB for the database. Correct answer: A. Use auto-scaling with EC2 instances and elastic load balancing, and store session state in DynamoDB. Use RDS MySQL with read replicas for the database. Explanation: auto-scaling and ELB ensure that your application can handle traffic spikes efficiently. DynamoDB provides a scalable solution for session state storage. RDS MySQL with read replicas handles millions of read requests effectively. Why not other options? Option B. Storing session state on EC2 instances does not support horizontal scaling effectively. Option C. Lambda has execution time limits and may not handle long-running operations or complex e-commerce logic. Option D. Storing session state in S3 introduces high latency compared to DynamoDB. You are building a data analytics pipeline to process IoT sensor data in real time. The pipeline must ingest data at high throughput, process it in near real time, and store it for querying. The solution must scale automatically and be cost-effective. Options: A. Use Kinesis data streams for ingestion, Lambda for processing, and S3 for storage. Query the data with Athena. B. Use Kafka on EC2 for ingestion, EMR for processing, and Redshift for storage. C. Use Kinesis Firehose for ingestion, AWS Glue for processing, and S3 for storage. Query the data with Athena. D. Use SQS for ingestion, EC2 instances for processing, and DynamoDB for storage. Correct answer: C. Use Kinesis Firehose for ingestion, AWS Glue for processing, and S3 for storage. Query the data with Athena. Explanation: Kinesis Firehose automatically scales for high-throughput ingestion and supports direct delivery to S3. AWS Glue is a serverless ETL tool, ideal for transforming the data. Athena enables cost-effective querying of data stored in S3 without the need for a traditional database. Why not other options? Option A. Lambda may struggle with real-time processing for high-throughput pipelines. Option B. Managing Kafka and EMR on EC2 adds operational overhead. Option D. SQS is not designed for real-time ingestion, and EC2 requires infrastructure management. Your company runs critical applications on premises. You need to design a disaster recovery (DR) solution in AWS. The DR environment must remain cost-effective during normal operations, but scale up quickly when a disaster occurs. Options: A. Use EC2 on-demand instances in AWS regions with a multi-AZ RDS database. B. Use a pilot-light strategy with minimal EC2 instances and a scaled-down RDS database. C. Use an active-active setup with data replication across AWS and on-premises. D. Use S3 for backups and spin up EC2 instances only during a disaster. Correct answer: B. Use a pilot-light strategy with minimal EC2 instances and a scaled-down RDS database. Explanation: Pilot-light keeps a small, scaled-down version of your infrastructure running in AWS. This minimizes costs during normal operations and allows you to scale up quickly during a disaster. Why not other options? Option A. On-demand instances and multi-AZ RDS are costlier as they run continuously. Option C. Active-active setups are expensive and may not be necessary for Doctor. Option D. Spinning up instances from S3 backups adds significant recovery time. You are designing a multi-tier web application with a web front-end, an application layer, and a database layer. The application must be highly available, scalable, and cost-optimized. Options. A. Use EC2 instances with an ALB for the web front-end, ECS for the application layer, and Aurora serverless for the database layer. B. Use Lambda functions for the web front-end, Fargate for the application layer, and DynamoDB for the database layer. C. Use EC2 instances with an NLB for the web front-end, autoscaling for the application layer, and RDS MySQL for the database layer. D. Use Elastic Beanstalk with an ALB and RDS PostgreSQL for the database layer. Correct answer, A. Use EC2 instances with an ALB for the web front-end, ECS for the application layer, and Aurora serverless for the database layer. Explanation: ALB provides load balancing for the web tier. ECS with Fargate manages containerized application workloads without managing servers. Aurora serverless is a cost-effective and scalable solution for the database layer. Why not other options? Option B. Lambda is not suitable for hosting web front-ends. Option C. NLB is not optimized for HTTP/HTTPS traffic compared to ALB. Option D. Elastic Beanstalk simplifies deployment but is less flexible for large-scale architectures. You need to connect your on-premises data center to AWS to run a hybrid cloud environment. The connection must be highly available, with low latency and consistent performance for applications. Options. A. Use a VPN connection with Direct Connect as a backup. B. Use AWS Direct Connect with VPN as a backup. C. Use VPC peering with a Direct Connect gateway. D. Use a transit gateway with VPN tunnels. Correct answer, B. Use AWS Direct Connect with VPN as a backup. Explanation: Direct Connect provides low latency, high bandwidth, and consistent performance for hybrid cloud setups. VPN serves as a reliable backup in case Direct Connect fails. Why not other options? Option A. VPN as the primary connection doesn't provide low latency or consistent performance. Option C. VPC peering is for connecting VPCs, not on-premises data centers. Option D. Transit Gateway supports complex networking but doesn't match the performance of Direct Connect for hybrid setups. You need to archive video files generated by a media processing application. The files are rarely accessed but must be retained for 10 years for compliance. Retrieval times of a few hours are acceptable. Options. A. Use S3 standard IA with bucket versioning enabled. B. Use S3 Glacier Deep Archive with a lifecycle policy. C. Use EFS with lifecycle policies to move files to infrequent access storage. D. Use S3 Intelligent Tiering with automatic archival enabled. Correct answer, B. Use S3 Glacier Deep Archive with a lifecycle policy. Explanation: S3 Glacier Deep Archive is the most cost-effective solution for rarely accessed data with long-term retention needs. A lifecycle policy automates the transition of objects to Glacier Deep Archive. Why not other options? Option A. S3 Standard IA is more expensive than Glacier Deep Archive for long-term storage. Option C. EFS is not suitable for archival workloads. Option D. Intelligent tiering adds overhead costs for long-term infrequently accessed data. You are designing a globally distributed web application. The web application must serve content with low latency to users worldwide. The backend application must also maintain low latency while accessing data that is replicated across multiple AWS regions. Options. A. Use CloudFront for content delivery, Route 53 for DNS routing, and DynamoDB global tables for the database. B. Use CloudFront for content delivery, Global Accelerator for routing traffic to the nearest region, and Aurora Global Database for the database. C. Use S3 Transfer Acceleration for content delivery, Global Accelerator for DNS routing, and RDS with read replicas for the database. D. Use CloudFront for content delivery, Route 53 for DNS routing, and RDS multi-AZ for the database. Correct answer, A. Use CloudFront for content delivery, Route 53 for DNS routing, and DynamoDB global tables for the database. Explanation: CloudFront ensures fast content delivery globally using edge locations. Route 53 provides low-latency routing for DNS queries. DynamoDB global tables replicate data across multiple regions for low-latency reads and high availability. Why not other options? Option B: Global Accelerator is better for dynamic traffic rather than static content delivery. Option C: S3 transfer acceleration does not replace CloudFront for efficient web application delivery. Option D: RDS multi-AZ does not replicate data across regions. You need to process and analyze large volumes of data collected daily from sensors. The data needs to be ingested into a data lake for storage and then queried by analysts. The solution must be cost-effective and serverless. Options: A. Use Kinesis data streams for ingestion, S3 for storage, and Redshift Spectrum for querying. B. Use Kinesis Firehose for ingestion, S3 for storage, and Athena for querying. C. Use EMR for ingestion and processing, S3 for storage, and Glue Data Catalog for querying. D. Use Data Pipeline for ingestion, S3 for storage, and Redshift for querying. Correct answer: B. Use Kinesis Firehose for ingestion, S3 for storage, and Athena for querying. Explanation: Kinesis Firehose is serverless, cost-effective, and delivers data directly to S3. S3 serves as a data lake for large-scale, low-cost storage. Athena allows querying data directly from S3 without setting up infrastructure. Why not other options? Option A: Redshift Spectrum adds unnecessary complexity and cost compared to Athena for direct S3 querying. Option C: EMR introduces infrastructure management overhead. Option D: Data pipeline is less scalable for high-throughput ingestion. You need to allow an external partner to access a specific S3 bucket securely for uploading files. Access must be temporary, and the partner should not gain access to any other resources. Options: A. Create an IAM user for the partner and attach a policy granting access to the bucket. B. Generate a pre-signed URL for the bucket and provide it to the partner. C. Use AWS Transfer Family to create a secure transfer endpoint for the bucket. D. Create a VPC endpoint for the bucket and allow access from the partner's IP address. Correct answer: B. Generate a pre-signed URL for the bucket and provide it to the partner. Explanation: Pre-signed URLs provide temporary, fine-grained access to S3 buckets without creating IAM users or managing credentials. Why not other options? Option A: Creating an IAM user adds unnecessary security risks and management overhead. Option C: AWS Transfer Family is for managed file transfers over SFTP/FTPS/FTP, which might not fit this use case. Option D: VPC endpoints are for private network access, not external partner access. You are building a fraud detection system for financial transactions. The system must process incoming transactions in real time, apply machine learning models, and notify downstream systems about suspicious activity. Options: A. Use Kinesis data streams for ingestion, Lambda for processing, and SNS for notifications. B. Use SQS for ingestion, EC2 for processing, and SES for notifications. C. Use Kinesis data streams for ingestion, SageMaker for processing, and EventBridge for notifications. D. Use Kafka on EC2 for ingestion, EMR for processing, and SNS for notifications. Correct answer: C. Use Kinesis data streams for ingestion, SageMaker for processing, and EventBridge for notifications. Explanation: Kinesis data streams supports real-time ingestion of financial transactions. SageMaker is a managed service ideal for deploying ML models for fraud detection. EventBridge handles event-driven notifications. Why not other options? Option A: Lambda is unsuitable for advanced ML model processing. Option B: SQS is not designed for real-time ingestion. Option D: Kafka and EMR introduce unnecessary complexity and operational overhead.